Am I audible?
Yes.
Okay. So good afternoon, everyone. I hope you all are doing fine. My name is Swantika Gupta, and I'm a software engineer at Nolders. And for today's knowledge session, I'll be your host. And today's knowledge session is on Morpheus, which is the Cypher for Apache Spark. Before diving into the Morpheus and its use cases, let's just first go through the knowledge etiquettes. So the first etiquette is punctuality, which asks the listener to be on time for the session. As a journal courtesy, it would be better to avoid joining the session post the 5-minute threshold. Please keep your cell phones on silent mode. And since we're working on remote, I would request you all to please keep your screen on mute until and unless you have a question. Please avoid unwanted chit chat during the session. And most importantly, please provide a constructive feedback to the presenter as it would be helpful for them. So the agenda for today's session is, first of all, we will be discussing why are we even talking about Morpheus. Then some of the key concepts in Morpheus, like property graph model, Cypher, and the syntax to Cypher. And finally, we'll see what Morpheus is all about. And we will end the session with a small demo on Morpheus. So first of all, why are we discussing Morpheus? So basically, last year, graphs have entered the Spark environment, and not as just an external plugin anymore, but as a core component. So for the past few years, Neo4j had a project which was called Cypher for Apache Spark, or in short, CAPS. Now it is renamed to Morpheus, and that is what we will be talking about. So Morpheus brought Neo4j's property graph model and its query language, Cypher, to the Spark environment as an external plugin. So it saw a lot of success. Many projects kept using it and were happy with it. So finally, last year or so, Neo4j decided that it would propose to Spark Apache, Apache Spark, to introduce Morpheus as a core component in the Spark 3.0 release. And I guess last year, at the end of the last year, Apache Spark accepted that proposal and said, okay, we will include Morpheus under the name Spark Graph to Spark 3.0. So that was a good thing that it was happening. That would mean that all of the graphical analytics which Neo4j provides via its query language Cypher and its property graph model, it would be available to Spark as well. And the other plus point was that Apache Spark said that not only we will include Cypher, but it will also provide an interoperability between the existing Spark SQL, which is used for tabular use cases, and the Cypher querying, which would be used for graph use cases. So that was the complete plan until last year, when it was popularized that Morpheus and Cypher would be a part of the Apache Spark environment. But with the release of 3.0, Cypher was not found there. So Cypher and property graph were not a part of it. Maybe they would be in the future, but right now they're not a part of it. So if Apache Spark decided, or maybe came to a conclusion that they should include Morpheus into their environment, so why not we go ahead and discuss a little about what Morpheus is and what are its core concepts, so that as and when Apache Spark do decide to introduce Morpheus into their environment, we'll have a background of what all it is about. So I have used terms like property graph model and Cypher a lot now. So let's just start with a basic introduction as to what property graph model is. So in our graduation or in our universities or colleges, we knew a little something about graphs. So in a layman language, a graph has nodes that relates to other nodes via edges, and those edges represent a relationship between those nodes. Well, property graphs are nothing else but an extension to those elementary graphs only. Along with nodes and relationships, property graphs also have labels, something called as labels, and key value property pairs. Now, what labels are and what key value properties are, so we'll discuss them in a later slide. But right now, just let's, as a refresher, go through what those basic entities in an elementary graph and in a property graph are. So first is a node, which is the basic entity in a graph, and it represents an object or a custom or a user created object, and it can hold a number of key value pairs, which are its properties. And to uniquely identify a node, that this node belongs to what category or what is its role in a particular domain, we tag each of this node with a label. So that is where labels come in. Similar things happen with the relationship as well. Relationships are basically directed. They go from one node to another, and they are named. and they always have a start point and an end point and a direction. They can also have different properties, which are key value pairs, so as to represent the type of relationship or some properties of the relationship between those two nodes. Now, the important point to remember is these nodes and relationships, which are the basic entity in a graph, they form a very powerful piece of the property graph model, and hence Cypher, that is known as a pattern. We'll look into it, what basically a pattern is and how it is created and represented. But just a little, point to remember, PTR, that nodes and relationships together form something important that is known as a pattern. Now let's look into what is the difference between a relational data model and a property graph data model. So a relational data model has a number of tables which are called as relations. We already know that. And those relations have rows. And those rows maintain records. So in our use case, in an instance, let's take that we have 3 different tables. One is a table or relation of employees, which holds all the employee information with a unique employee ID representing a row. Then we have a list of departments, which holds a list of all the departments and a department ID, which uniquely identifies it. Now an employee belongs to a particular department. And this relationship in a relational data model is represented using a third table here, which is represented as department underscore members. So here we use the key of the employee table and the key of the department table and create a relationship between them. In a scenario where we want to represent this exact same thing using a property graph data model, what we'll do is we'll pick up a row from the employees table, and that row becomes a node. So in case of a relational model, all the rows together form a table. But in case of a property graph model, each row forms a separate row. Now, so here in this example, Alice is a node. And that node belongs to, what is that node actually? It is a person. So we represent it with a label, that is person, and the colon that is prepended to it, it's just a syntax which is used by property graph model and Cypher. So that is how we have represented it here as well. Similarly, department and each department row is an entity. So all of those rows represent a separate node. So as we can see on the right side of the diagram, we have separate rows which are represented as separate nodes. And each node has the same label, that is department. And if I say that the node Alice or the person Alice belongs to a department A42, then there is supposed to be a directed relationship between them, which is represented by a straight line with an arrow and a label to it, which represents the type of relationship between those two nodes. So here I read it as Alice, who is a person, belongs to A42, that is a department. So this is how a property graph model is read. Another term that we generally see when you will study about property graph model is that a property graph model is whiteboard friendly. So what that means is, let's consider a scenario where you have to create a database for your project using RDBMS or a relational data model. So as a basic concept, what you'll do is you'll go ahead and create an instance of, for example, a person and a department, and you'll draw an arrow to represent the relationship between those. Now, since you want to create it into an RDBMS, you will draw an ERD and represent its various labels there or its various properties there. And then you will try to fit in your data model that you have created into a normalized table. So finally, the result that would be stored in the database in the form of a table would be a little different, or maybe a lot different, and surely complex than what you just represented on your diagram or on your paper or on your whiteboard. So that is not at all what you visualized it to be and how it turned out to be. But a property graph model resolves that problem. So what you do is whatever you create on your whiteboard or on your paper is what you'll get as the end product as well using the graph model. So for example, in this particular slide, I have created a whiteboard model where I'm showing a relationship between actors and the movies that they have acted in. So for example, I have 2 actors, Jack Nicholson and Tom Cruise, who have acted in a movie called A Few Good Men. And also Tom Cruise has acted in another movie called as Top Gun. And I've represented this relationship with a label acted in. So this is what I draw on a paper or in a whiteboard when I'm, for example, trying to explain it to a friend or a colleague. Now, this is to be a little bit formalized. So this is what we get in the next part of the image. When we formalize this white model and add certain syntax to it, this is what we get. And it is almost similar to what I drew into the whiteboard model. Going ahead, to those nodes that I've created. So whatever I drew on my paper actually is a node. So here I'm getting a node with the name Jack Nicholson and another one with the name Tom Cruise. So here no name becomes a key and Jack Nicholson or Tom Cruise becomes a property of that node. And also I'm representing some labels with it. So here I'm saying that both these persons are actor as well and both these nodes are person as well as an actor. So that makes logical sense as well, and as well I can represent it in a property graph model easily. So a node can have a lot of labels according to the domain in which you're using it. In case of a simple case where I'm just representing persons, I'm using the same nodes with the label person. And when I'm creating a particular use case for movies only, then I'm representing them as actor. Similarly, the movie node could be represented with a simple label which represents movie. And even the relationship that I created can be represented with an extra property, that is the year in which that movie was released with that actor. So here I have certain years added to the same labels. Now, finally, this is the input to my graph, and the final model, which is stored in the Neo4j, looks exactly same as I have created in my property in my whiteboard. So I have the same circles, the same arrows, and the same data as well. So visualization becomes what is actually stored into the graph database. So here the property graph models are really important. And why am I talking about visualization about so much is because I want to introduce Cypher to the platform as well. So basically what Cypher is Neo4j's graph query languages, which is declarative. So I don't have to tell it how you have to pick data from a graph. I'll just have to tell it you have to pick up a data and it will figure it out how it has to do it. And it is SQL inspired. So how SQL is declarative and how its syntax changes, that is how Cypher also works. And a very important aspect of Cypher is that it uses ASCII art syntax. What ASCII art means is that I have all these keys on my keyboards, and using these keys, I can represent nodes and relationships or graphs properties altogether. So only the keys which are required, which are present here, I can use them to create symbols to represent nodes. And we'll see that how it is done in the further slides. And why this is important is because Cypher basically describes visual patterns in a graph. As a human, we perceive visuals very clearly. We see something and we recognize what is its relationship with the other thing in the diagram. And that is how Cypher is created. Cypher allows you to visualize what you are imagining and create a graph out of it. And Cypher is heavily based on patterns, and those patterns are created using ASCII art, and it can recognize those patterns efficiently. And why Cypher is also important is because it is a key inspiration for a very important project going on, that is creating a graph query language, which is a general purpose graph query language which would be used in future. So Cypher is also major inspiration for that. Now, let's look at the patterns I was talking about. I have been talking about patterns in the property graph model as well as in the previous slide. So when you have to create a node, what you do is in a graph, in a paper model or in a whiteboard model, what you do is you create a circle and represent its properties inside that circle itself. So this is how we create a node in a Cypher syntax. So what we do is we open a parenthesis, present the node that we want to create, the label of the node we want to create, certain properties that we might want to add, and then close it. So this is my one node. Similarly, I have another node, that is the movies node, which also works in the same way. I open a parenthesis, close it, and then in between, I represent the label that I'm talking about and the various properties that I'm talking about. Now, these two nodes, when I'll draw it on a whiteboard or in a paper, I will connect them via an arrow, right? And represent a name or a label on it, which will represent the relationship between those nodes. And that is how I create it in Cypher as well. I just use the arrow operators, and in between, using square brackets, I represent the label or the relationship between those nodes. So just to sum it all up, for nodes we use we use circle brackets, and if we keep it empty, then it represents any node in the graph. So I'm not limiting it to a particular label or to a particular table as we used to do in RDBMS. Here I'm just saying that it is any node. It can be of person type or it can be of movie type. And if I represent a variable inside it, So this means that this particular node has a variable name now attached to it, that is P, and I can use it in my further syntax. But if I want to limit it to a particular type of label, so I can do it in this way. I can just represent the variable name, colon, the label to which that particular node should belong. So this restricts my cipher to only look for the node in the given label, that is the person label only. Similarly, for relationship, I use arrows. And if I'm not sure of the relationship as to what is the direction of the relationship, I can just represent using 2 dashes without the use of arrows. Now, if I don't specify the type of relationship that I need to look for inside the two, in between the two nodes, then I just specify it openly like this, what I have represented in the first line. So this means look for any relationship which might exist in node A and node B. But when I specify a label or a relationship type between those arrows, then it represents that for those nodes A and B, only look for the relationship with the label acted in or the type acted in. And if I append REL as I've appended here to the same data, it means label to this relationship which can be further used. So for example, for this relationship, I might have some extra properties like the year I was born in, the month I was born in, the date I was born in, the city I was born in, and the year I was born in. So these properties can be further used. So for that, I use the return keyword. So return keyword specifies the node of the particular relationship with the label acted in. So this is how I create a pattern in Cypher using nodes and relationships. So this is how a complete pattern is created in Cypher using nodes and relationships. Now, using this thing, we have only created a pattern, but we have not told Cypher what to do with that pattern. Do I want to look for that pattern? Do I want to insert that pattern? Do I want to delete that pattern? That is not done yet. So the next thing we'll be talking about is the reserved keywords, which are used in Cypher to depict all the actions that we want to do with that pattern. So first and the most easily used and the most understandable, according to me, is match and return. So when we use a keyword match followed by a pattern, we tell Cypher to match the pattern that I have passed you in your graph database and look for those exact nodes and those exact relationships. So that is similar to SQL's select statement. Using a match, I can pass a node or a relationship or a property or a label or a pattern. Anyhow, any of these values can be passed, and Cypher would look for that particular matching an entity only. Now, once Cypher has matched it, it should know what it should return to me. So for that, I use the return keyword. So return keyword specifies the node if you want to return it, the relationship if you want to return it, the node or the relationship's properties, or the complete pattern. So using match, return, and the pattern that I've created in the previous slide is what is called as pattern matching, which is very essential to Cypher, and it is one of the most important point of Cypher. Apart from match and return, we have other reserved keywords as well. So before going on to that, let's just go through some of the examples which basically talk about match and return. So for example, I have a node of person label, and I want to look for all the nodes which belong to that particular label. So what I'll do is I'll ask Cypher to match this particular pattern, that is a node, which is a circle, almost a circle, with a label person, and return that particular node. So this is what the first example would do. Second, I want to find a node with label person and the name as well. I want to find a person whose name is Hugh Jackman, and I want to return the node. So this is how I will do that. I will specify a variable name, the label, the property that I want to look for, and I would return the complete node. Similarly, now I want to find for a node, I want to find for the movie in which a person with the name Hugh Jackman acted. So this is how I create a pattern for that. I have a node that is of type person. I specify its properties, that is name Hugh Jackman. I specify that he has acted in a certain movie, and I'm not sure what that movie is. So I want Cypher to look for that movie for me. So I will specify return that movie M. That is the variable I've assigned to the label. Finally, I want to, next step is now I want to just want to know the name of the movie. So what this third statement would do is it would return all the properties of the movie node, irrespective that if I want them or not, it would return the complete node. But now I want to I want to see only a certain property of that particular node. So I specify it using a period and followed by the property that I'm interested in. So for example, here, the movie node has a property name, and I just want the name of the movie in which Hugh Jackman acted and not all the other things related to that movie. So this is how I specify it using dot and followed by the property that I'm looking for. Then I have another use case where I want to, now Hugh Jackman might have acted in a lot of movies, but I want to just limit it, that I want to see only those movies in which he acted in the year 2008. So this is the property of the relation and not of the node. So I can represent the same using curly braces inside the relationship label. So I specify the node, look for Hugh Jackman, and we see only those relationships which had a year property set as 2008 and search for only those movies and return the name of those movies. So these are certain use cases or examples where pattern matching, match and return is used. Apart from those reserved keywords, the most important ones apparently, the match and return, we have other keywords as well. That is, if we want to create a node in a graph, what we will do is we'll just match a pattern and specify the create keyword and tell it what to create. For example, here I have two matches. First is looking for a matched person label, and the other one is looking for a movie label. And now I want to create a relationship between them. So this is how I create it. I pass the keyword create using the variable name of my source node, passing the relationship between them, and followed by the end node or to the target node. Now, again, if I already have a node and I want to update its certain properties, that can be done using the set keyword. So I specify the matching pattern to be used. Once Cypher has found that matching pattern, it would update its birth date property to the value provided. Now I want to delete a node or a relationship. In that case also, I tell Cypher to match this particular pattern, which is a node here, and simply delete it. Instead of returning it or doing anything with it, I just want to delete it. Now, this might create a problem because it might delete a node, but it would give an error because there might be certain relationships which are existing with that node only. So that would be a breach. So I can use another command, that is detach delete. So what this does is it not only deletes the node that I want to delete, but also deletes any type of relationship which might be coming into it or maybe moving out of it. So detach delete deletes the node as well as any relationship which might exist with that node. So these are the CRUD statements which can be used in the Cypher syntax and property graph model. Now, since we are familiar with a little of property graph model and Morpheus, let's just talk a bit, property graph model and Cypher. Let's just talk a bit about Morpheus. That was the main aim of the session. So Morpheus was originally called as Cypher for Apache Spark, and in short, CAPS. It was written, or it was presented as a way of bringing graph processing and analysis to Apache Spark. So when Morpheus was brought in, the idea was that right now all the analysis is done on the tabular data. But what if a use case arises where a problem could be solved efficiently using graph analysis or the graph algorithms that already exist instead of the tabular data? So that was the idea behind Morpheus. So that is how they came up with Morpheus and said that right now Morpheus would be used as an external plugin. So we create a Spark application and add an external plugin as Morpheus, and that gives us all the graph capabilities that are present in property graph model as well as in Cypher. So Morpheus is easily integrated with Hive, Neo4j relational database, and any file stored in HDFS or S3. For our demo, we will be reading a simple CSV file from my local system and see how we'll be working with that. Now, since Morpheus is brought to the Spark environment, it can run analytic graph queries there, and it can also use the Spark special features such as Catalyst Optimizer. So that is also a plus point. And as I have said earlier, Morpheus actually allows interoperability between data frames that are a component of the Spark SQL and graphs that are a part of property graphs. So we can easily convert a data frame to a graph, process it using graph queries available, and then convert it back to data frame and let it go through the other pipelines which might be expecting a data table. So this is how Morpheus is integrated inside Spark. So before moving on to the session, a little glimpse in all that we'll be seeing in the session. So Since we are trying to integrate Morpheus into a Spark session, the first step would be to create a Spark session. And once that Spark session is created, we will use a Morpheus session to create an entry point into the property graph model and the Cypher language properties that are available using that Morpheus session. Next, you will see that we already have a data frame and we want to convert into a node, but we don't know what properties of the data frame are properties of the node. So for that, we use an element mapping node. What this element mapping class or object does is it would allow us to map our CSV columns or our data frame columns into properties, and those keys would be taken from there. And also we can specify the ID. Since it is a node, it would have a ID, unique ID. So we can specify which column should be taken as a node, and we can specify the label as well. So now we have a data frame. We'll see in the demo how this data frame is created. We have a data frame and a mapping of that data frame. Using both of this, we finally create a node. So we have this Morpheus element table.create method, which takes the mapping and the data frame and converts it into a node. So, using this criteria only, we will create nodes as well as relationships. And finally, using all the nodes and the relationship, we will create a property graph. And all the Cypher queries can finally be executed on this graph. So before I go ahead with the demo, is there any question? Okay. So we'll just go through the demo for this for the Morpheus. So as I've said, we will first create a Spark session, and using that Spark session, we will create a Morpheus session. Now, this Morpheus session is the entry point to all our property graph given in the Morpheus, as well as the Cypher language capabilities. Now, the use case is such that I have certain CSVs. I have a CSV of persons, which basically contains the movie actors and the year they were born in and certain other information about their IDs. Then I have movies in which they might have acted with the movie ID, the title of the movie, the tagline of the movie, and the duration for which it ran, and rated, what is the current rating of that movie. And I also have a CSV which represents the relationship between those actors and those movies. So for example, I have a relation ID 1, which specify that the start ID is 1 and the end ID is 28, which means that person with ID 1, that is Keanu Reeves, worked in a movie with ID 28, that is Matrix Reloaded. So this is how the relationship is specified in the acted in CSV file. So now this a scenario might exist that this CSV came in from a separate part of pipeline of the Spark processing, or it might came in the form of data frames. So what is the first step that I do is I just convert the CSV into data frames. So that is a simple read operation that takes in a Spark session, reads it with the specified CSV properties, and stores it in a data frame. So I have read all the three CSVs that I've shown here, the movies.csv, persons.csv, and the actedins.csv. Once the node is created, now I want to create a mapping. So I take one by one each node and create a mapping to it. So for example, I have a movies node where I have a movie ID. That should be my source ID. Then I specify it with a label, that the label of this particular node would be movies. And the different columns that are present in my movies.csv, I specify them as different properties. So I give them the same name as was available in the data frame. Similarly, for the persons DF, for the persons data frame that consists of the data of actors, I do the same. I specify the person ID column should be taken as the source ID and the different properties it should take, and the label should be person. And finally, I come into the relationship where I tell it that the relation ID column should be taken as the ID for the relationship, and the source start ID is the start ID column. The source end ID should be the end ID column, and the relationship type is acted in, that is the label of that relationship. And I have a property there that is role, which specifies the role that actor played in that particular movie. Once we have the relationship, once we have the mapping and the data frames ready, we use another method, that is Morpheus element table.create, which takes the mapping and the data frame to create a node. So here I create the node for movies. Here I create the node for persons, and finally the relationship between them. And using all this information, all the 3 nodes and the relationships that I have, I create a graph. Just a second. Okay. So using all the 2 nodes and the relationship, I finally create a property graph. Now my graph is ready, and all of my different Cypher queries that I just saw in the slide could be used here. So let's start with them one by one. So first of all, what I want to do is, I want to get all the nodes which have the label person and which have the label movies separately. So these are my 2 queries. I tell Cypher to match a person node and return its name, and alias it to an actor name. So that is what my use case is. And similarly, I do it with the movies label as well, that get all the nodes which are present under the label movies and give me their titles. So we'll just run it. Okay, so here we have all the names of the actors which are present in my data frame under a column actor name, and all the movies which are present in my movies.csv file under the name movie titles that I've aliased in my code itself. Now I have all the nodes. Now I want to see the relationships which exist between the movie nodes and the actor nodes. So I've asked Cypher to match pattern like person who has acted in movies, and every node which fulfills this pattern should return the person name as the actor name and the title as the movie title. So I want to see the relationship which exists between the existing data. So I'll just comment out the previous code. Let's run it again. Okay, so here is the data. It has created a relationship between the different actors and the movies that they've acted in on the basis of the source ID and the end ID that I provided. So I have got the data right here. Now the next query is that I want to see data for a particular actor with the name Keanu Reeves, and I want to see all the movies that he has acted in and the role in which he was casted. So this role is a property of the relationship and it's not a property of the node. So I want to see which movies did he acted and the role he had in that particular movie. So let's run this code again. Yeah. So for Keanu Reeves, we have 3 records. That is the metrics, metrics evolutions, and metrics reloaded. And we see that his name or his role in all of these 3 movies was Neo. So moving on, another use case might be where we have a property of the relation and we want to use it as a filter. So this is what we're doing here. We are asking Cypher to match query like we have a movies node, we have a person's node, and we have a relationship between them. And that relationship has a property role, and the property's value should be Neo. I don't want to look at any other relationship that might exist in between both of these nodes. I just want to look for the relationship which has the property Neo. And as you can see here, I have not shown the direction of the relationship between those nodes. So it can be any way. Maybe I'm not sure about the type of relationship, the direction of relationship that might exist here. So I've just left it without an arrow. And I'm asking it to return the name of the person and the title of the movie that he has acted in with the name Neo. as far as this is executing, let me just discuss about the next query in line. So this is something that is like, that will be, if we integrate Morpheus in a project, that will be used really much. So this is about parameter substitution. In all the previous queries, what we have done is we have specified the values inside the query. We have like statically typed it there. And maybe we don't want to do that. Maybe we want to take the input from the user and then use the parameter there to use to in a query. So that can be done as well. So we have we create a Cypher map basically, which takes the name of the parameter and the value that you want to assign it. So this is the name of the parameter that I will use in my query forward. And this might be the value which the user passes right now. So once I've created a Cypher map, I can use it in my query. I just represent my query as normal. And in the place of the actual static data that I present, I just type in with the name of the parameter that will be substituted later on. And finally, I pass the parameter Cypher map that would be used for substitution. So this works as expected. For the first case, I get all the name of the person and the movies where there was a relationship with the role of Neo. So I get Keanu Reeves again. And then for the second part of it, I used parameter substitution, and I asked to look for all those movies, all those actors where the movie was A Few Good Men. So I want to look for all the actors who acted in the movie A Few Good Men, and I got the result as Tom Cruise and Jack Nicholson. So that worked out pretty well as well. Now, it's not just pattern matching that Cypher provides us, but we can do filtering and other sorts of things that we do with SQL as well here. So for example, let's look at examples here. So in the first case, I'm using a where filter, where clause, which would just filter out my nodes on the basis of the properties that I'm passing here. So if I'm not going to use pattern matching, I might want to use where clause to filter out those results. So this is what is happening here. I'm specifying Cypher to look for a person node. And in those nodes, all the nodes that it might find, I want to filter it to only those nodes which contains the name Keanu Reeves and return it as under a certain column name. So this is what is happening in the first result. I'm getting a person label. And as you can see in the output as well, that it is represented within double brackets. If it is represented between an opening and a closing bracket, then that is how a node is represented. Now, in another use case, I might want to order all my movies on the basis of the duration for which its running duration. So I ask Cypher to match my query again, that is look for only movie labels and order those nodes that I get on the basis of the duration. That is a property of those nodes. So this is the result that I'm getting, and it shows that matrix revolutions has the minimum of the duration type, while A Few Good Men has the maximum. And finally, I can use aggregation methods as well. For example, minimum, maximum, count. These methods are also available to use in Cypher. And that is how we represent it. We just return it and specify the method that we want to use on which property. And we get the result here. Another approach that we might want to use instead, if we are not interested in creating a mapping away all the way. So what another approach that we can use is, okay, yeah. So we have another method that is Morpheus node table, which basically takes a set of labels that we want to create and the node that exists. So basically, what it is doing is it is creating a node and assigning a label to it. So instead of writing all those mapping code in between, we can specify it here only. But again, there will be certain renaming of the column required. Since we are reading it from a CSV and it is a data frame, all the SQL functions like column renaming is available to us. So we can simply go ahead and take care of the IDs, take care of the symbols that it requires. For example, every node should have an ID. So I specify that movie ID should be renamed to ID so that it can be used as a node ID. Similarly, in the relationship, for a relationship to exist, every relationship should have a relationship ID. Under the literal ID, it should have a source, and that is how it is renamed here, and a target. So after this is done, this would behave exactly the same way as was expected in the previous example. Apart from that, a small point here is that right now Cypher does not support, it only supports a small amount of Morpheus only supports a small amount of Perl operations that are available in Cypher. So right now, Morpheus does not support any of the commands which intends to update the existing database. It is not intending in creating a node or deleting a node or updating its properties. So we do not have these properties, that is create, set, delete, and detach, available in Morpheus, but all the other properties that are required for pattern matching or maybe aggregation are implemented. So that's it from my side. Any questions?
I guess there are none.
Okay. Thank you so much, everyone.
Yep, thanks, Kuntika.
Thanks, Gunjan.